Welcome to my brand new machine learning tutorial series. In this tutorial series, I will be making a couple of videos in which you will learn how to program machine learning algorithms using TensorFlow and scikit-learn. It will be a complete hands-on machine learning experience for you. So I hope this video series will help you to become a machine learning engineer and will help you in your research job or in your study purposes. So let's dive into the video. So what is machine learning? It is a subset of artificial intelligence, and it gives computers the ability to learn without being explicitly programmed, according to Arthur Samuel. So alternatively, we can say that it's the science and art of programming computers so that they can learn from data. So as you can understand that data is the main fuel of machine learning. Without data, machine learning algorithms cannot work. So why we use machine learning? So if you see the traditional programming techniques, so traditional programming, for example, there are some problems like email spam filtering. So if we try to traditionally program them, there will be a long list of complex rules which is pretty hard to maintain. But if you use machine learning techniques, it automatically learns which words and phrases are good predictors of spam by detecting unusually frequent patterns of words in the spam example compared to the ham examples. So the machine learning program is much shorter and easier to maintain, and most likely more accurate. So machine learning technique automatically notices those frequent patterns. So machine learning actually excels for problems that are either too complex for traditional approaches or there is no known algorithm to solve using traditional approaches. So if we hard code an algorithm that will be like, there are lots of parameters, lots of patterns, and huge amount of code will be there. So it is easier to code using machine learning and easier to learn and predict. So actually it gives higher accuracy. So like there is a common workflow in machine learning that first of all we study the problem, and then we collect data set, we train the ML algorithm, and then we inspect the solution, and then we understand the problem better, and if we need, like if we find inconsistencies in our data, we can update the data and again retrain. So basically machine learning is a iterative process. We'll have to try every time to improve our prediction and accuracy. So there are common types of machine learning. First of all, we have supervised learning. So in supervised learning there are some level data which the algorithm uses to learn. So it is actually with the help of kind of like a teacher which is always helping the model to learn. So it is under the supervision. So there is level data which helps the model to learn. So there are common type of supervised learning task is classification. So the spam filter example is a classification problem where we classify the emails into spam or ham, and the model learn to classify new unseen emails. So another type of supervised learning is regression, where we predict numerical values like housing prices, age, etc. So there is no class in regression. So common form of supervised learning algorithms are k-nearest neighbors, linear regression, logistic regression, support vector machines, decision trees and random forest, and also neural networks, which is part of deep learning. So we will also learn how to program these algorithms. So what is unsupervised learning? Unsupervised learning is training data where trained data is unlabeled, so the system learns without a teacher or a supervision. So there are common types of unsupervised learning algorithms, which are clustering, K-means algorithm, hierarchical cluster analysis, dimensionality reduction, principal component analysis, TSNE, etc. So we will learn how to program these algorithms in our next videos. So there is another common one called semi-supervised learning, where some data are labeled and some data are unlabeled. Also, an important type of machine learning is called reinforcement learning. So it is called completely different. In this learning system, there is an agent which observes the environment, selects and performs actions which gives the maximum reward, and it learns by itself by exploring the environment and chooses the best strategy called a policy. So we can also categorize or classify machine learning using other criteria such as batch learning and online learning. Batch learning is offline learning, that the model doesn't learn on the go. Doesn't learn incrementally. It first trains using all the available data and then it no longer learns. So basically there no new data helps the model to learn, so it takes a lot of time and computing resources. So it is typically done offline. So there is another learning called online learning. So in online learning, the system learns incrementally. The data is fed continuously in using small groups or called mini batches. So it is usually fast and cheap. The system learns continuously and adapt to the changing environment. So it is a good option if you have limited computing resources. Okay, so also there we can categorize machine learning using instant based and model based learning. So in instant based learning, the model learns completely by heart and requires some measure of similarity. So it generalizes to new cases using a similarity measure. So we will learn more about it in our future videos. And also there is another term called model based learning. So in model based learning, the algorithm learns to generalize from a set of examples to build a model of these examples. So they form a mathematical model which helps them to make predictions. So lastly, we need to know about some of the common challenges we face while we apply machine learning in real life. So mostly what happens is there is insufficient quantity of training data. So we will learn how we can solve the problem of insufficient quantity of training data, like using augmentation or other. There is also non-representative training data. Also there is poor quality data may come. There are irrelevant features might be there. Also their training data might overfit and might not be able to generalize well to new examples. So also underfitting might occur. So underfitting is the opposite of overfitting. So we will learn more about them in our future videos. Also there are some common terms like testing and validating which we will learn. So what we do is we split our data into two sets, training set and test set. So we train our model is in the training set, and the test set is used to generalize, to test how good our model generalizes to new data. So commonly there are 80% of the data is training and we hold out 20% for testing. So that's all from this video. In our next video we will learn how to program supervised learning algorithms using different data sets and how to apply machine learning in real life. I hope you enjoyed this video. I'm looking forward to my next video in which we will learn how to program machine learning algorithms. So I hope you all are doing good. That's all from today. Thank you all for your time, patience and understanding.